Let's talk about some of the accessory structures of the cutaneous membrane. We've got nails, hair, exocrine glands. Hair and nails are mostly composed of dead cells. They're made out of keratin. It's a different kind of keratin. It's called hard keratin rather than the regular kind, which is called soft keratin. Exocrine glands, on the other hand, are made out of living cells. Here we have the structure of a nail. We're not going to go into a lot of detail on the nail, but basically we have a nail bed which lies underneath the nail, and that's going to contain epithelial cells that are going to produce the keratin, and then as it gets older, it gets pushed out further and further and further. Nails are interesting in that you can pick up a lot of disorders by just simply looking at the nail. If your nails are brittle, that could be an indication of protein issues. They can be ingrown if they're not trimmed correctly. Onychomycosis is a fungal infection of the nail. Happens quite a lot with the foot. Yellow nail syndrome is when the nail gets unusually thick. You can have spoon nails or Bowes lines, even vertical ridging. Hair is found pretty much everywhere on the body except the hands and palmar surface of the fingers, the sides and soles of the feet and toes, the lips, and parts of external genitalia. There's three kinds of hair. Lanugo is a fine, unpigmented, downy hair that is only found on newborns. It appears in the last trimester and disappears pretty quickly. Vellus hair is the primary hair that we find on humans. It's found on upper and lower limbs. And then terminal hair is coarse, it's pigmented, it's longer than the vellus hair, and we find this on the scalp, eyebrows, eyelashes, in the beards of men. And during puberty, that terminal hair is going to replace the vellus hair in the axillary and pubic regions. When we look at a follicle, we've got different parts. There's the hair bulb, which is the swelling at the base that's down inside of the dermis. And this has a lot of vascular tissue and a lot of epithelial tissue to create the keratin. The root is the zone of hair from the bulb to the surface of the skin. And this is going to be composed of dead keratinocytes. The shaft is the part of the hair that pokes past the surface of your skin. The follicle has a tube kind of surrounding the root there. It has an outer connective tissue root sheath for protection, and then an inner epithelial tissue root sheath to produce the keratin. Now, most of the time, your hair follicles will have little tiny smooth muscles attached to them called erector pili muscles, and these will contract during certain times and cause goosebumps. So here we go. Here you can see the shaft of the hair all the way down to here. Here's the root, and then this little bit down here is the bulb. If we go in closer, we're going to see a little papilla right here. This is going to be extremely vascular. We've got a bunch of capillaries going up into there. And then we're going to have an inner epithelial sheath and then an outer connective tissue sheath, and that's going to be for the protection. Hair color comes from mostly melanin, although keratin can play a part. Hemoglobin does not color hair. As we get older, as individuals, we stop producing as much melanin, and hair starts to become kind of gray as we don't produce any more of that pigment. And then as we get even older, the hair shaft itself becomes kind of brittle and flawed, and there's lots of air bubbles that end up inside of it, and the air bubbles refract light and kind of scatter it, and that's when your hair becomes very white. You've all probably seen a little old lady go outside, and it's like a light bulb goes off. You know, the sun hits her head, and the whole thing just kind of glows. That's because of the white hair and all those air bubbles there. Now, normally we lose about 10 to 100 hairs per day. If you're losing more than that, it could mean a health problem, although not necessarily. You can have temporary loss due to all kinds of things, including drugs, diet, radiation, fever, stress. You can have your hair thin, and that's called alopecia. And most people do have alopecia due to aging. You can have diffuse hair loss, where it's coming from all parts of the scalp. We see this primarily in women. And this can be due to hormones, drugs, or iron deficiency or age. In men, we typically see the male pattern baldness. Moving on to the glands of the skin, we've got a lot of exocrine glands. The most common are going to be sweat glands and sebaceous glands. When we look at our sweat glands, there's two kinds. There's merocrine and apocrine sweat glands. Remember, the merocrine sweat glands are also known as eccrine sweat glands. These are going to be little coiled tubes where in the, we call it an acinus, where all of the epithelial tissue is going to produce a product, dump it into the tube, which in this case is just going to be kind of wadded up or coiled, and then the end of that tube will eventually open into part of the epidermis. So the merocrine or eccrine sweat glands are the most numerous and widely distributed through the body. They produce sweat through exocytosis, and sweat is about 99% water and 1% other things like electrolytes or metabolites or waste products like urea. Sweat's important for thermal regulation. It helps cool us off through evaporative cooling. We can also get rid of some drugs through sweating. We don't want to sweat too much because you can lose water and electrolytes, but sweat also does have some antifungal and antibacterial properties to it, which is kind of cool. Even your sweat is antibacterial. The apocrine sweat glands, as opposed to the eccrine sweat glands, also produce their products through the merocrine method and exocytosis. They're also coiled tubular glands, like we talked about, but they're located only in certain areas of the body. The axilla, around the nipples, and the pubic and anal pelvic regions. What these do is they're going to produce kind of a more viscous, cloudy secretion. It's going to have proteins in it. It's going to have some different lipids. And bacteria really love to eat this stuff. And as the bacteria grow in number, they can cause a pretty foul odor. And this is what is known as BO. These apocrine sweat glands only start to become active during puberty. So if you've ever been around like an 8 or 9-year-old child as they're running around in the hot sunshine and they're sweating, they smell like a sweaty little kid, but it's not a foul reek like an adult locker room. The sebaceous glands are holocrine glands. Now the holocrine glands, remember, do not use exocytosis. Instead, the individual cells fill up with their product and then burst, releasing that product. Sebum is a lubricant for skin and hair. It's bactericidal, and we usually have our sebaceous glands in conjunction with hair follicles. As the sebum is produced onto the root of the hair, it wicks its way up the shaft and onto the surface of the body. Other types of glands we have in our integumentary system are going to be ceruminous glands. These produce earwax or cerumen. This helps trap foreign material and helps to lubricate the acoustic meatus or your ear hole. And then mammary glands. These are a type of modified apocrine sweat gland, and this is what produces milk. So here's some examples. Again, you can see there's a sebaceous gland, and then here is an eccrine sweat gland, or in this case, I guess it's apocrine. So the only way to really tell is by knowing what part of the body you're in. The apocrine and the eccrine glands look remarkably similar. Now you'll notice that there are holes here. There's a lumen in these little tubes, whereas there is no lumen in the sebaceous glands. Remember, the sebaceous glands produce their product through the holocrine method, whereas both the apocrine and the eccrine sweat glands are going to use the merocrine method and exocytosis to put their product into a duct.